Okay, so before we do exact measures of trigonometric functions, let's first do a quick little refresher as far as what the unit circle has to offer in radians. So keep in mind that as we move this direction, we're going positive. This direction's negative. This point here is the point 0, 1. Sorry, 1, 0. To the right one, up and down 0. This point up here is the point 0, 1. As we start in radians, we understand that one complete time around the circle is a total of 2 pi. So halfway around the circle is going to be 1 pi. Up here we'll have half of a pi, or pi over 2. Down here we'll have 1.5 pi's, or 3/2 pi. So this is what we're going to be using when it comes to talking about finding angles in order to find exact values of trigonometric functions. So keep that in mind. The one thing I really want to stress here is that 1 pi is this. That's 1 pi. So if I'm talking 3/4 pi, or 3 pi over 4, that would be somewhere in here, because that's 3/4 of that piece. Okay, that tends to be the one that gets people the most. All right. So we want to find the exact value of each trigonometric function. The sine of 15 pi over 4. Well, first thing we got to do is we got to find where the angle 15 pi over 4 is. All right. Best thing to do, take 15, divide it by 4, and let's just see what mixed number we come up with, because that'll give me a whole portion of this and also a part of this. So 4 goes into 15 3 whole times. 3 times 4 is 12. I get a remainder of 3. I take my remainder, I put it over my divisor, 3/4. So this is 3 3/4 pi's. So I'm going to start over here, and I'm going to go 3 whole pi's and then 3/4 of 1 pi. So as I go around, this is 2 pi. Okay, let me erase that so we don't confuse it, but we've gone just going around 1 time is 2 pi. Now, as I go to here, this is another 1 pi, so that's 3 pi. I've gone around 3 pi. Alright, now I need to go 3/4 of another pi. Now the whole bottom part here is 1 pi, so 3/4 of this would be a half. Another 1/4 right here, that would be 3/4. Okay, so I went 2 whole pi, and then 1 more, and then another 3/4. So I know that this is a 45-degree angle because I went 3/4 of the way. I had to cut that last quadrant into 1/4. Okay, and if you're thinking in terms of degrees, well, that's going to be 45 degrees. So let me erase all this. Okay, now that we've gotten the angle, now this just becomes like the ones we just did with the degrees. We make a right triangle with a 90. Now we have a 45, 45, 90, so I'll put my little 45, 45, 90 template down here. I know that the two shorter sides are the same, and then the hypotenuse is n radical 2. Always remember that in the unit circle, every radius is equal to 1, is a length of 1. So this radius is 1. Now we already have practice doing the rest of this because these are just like the ones we just did. So if I'm going from a radius to a shorter side, I'm going to divide by radical 2. Because I'm going from n radical 2 to to just n, so I'm doing whatever I can to get rid of the radical 2. So if I do that, 1, that came out kind of weird, 1 divided by radical 2. Now, as badly as I just want to put that here, I can't put that there yet because that's not simplified. I can't have a radical in the denominator. So I'm going to go ahead and I'm going to multiply by radical 2 over radical 2. So the denominator is 2, the numerator is radical 2. So each of these sides are radical 2 over 2. So this point down here, just for future reference, is radical 2 over 2, because I'm going to the right. But then remember, I'm going down, so this is actually negative radical 2 over 2, because I'm going down from the x-axis. Alright, so they want me to do sine, the sine of 15 pi over 4. Now I know that sine, because of our friend SOHCAHTOA, is opposite. Let me just put that up here. This is opposite over hypotenuse. Alright, as I go back over here and I look at the angle of which I'm talking about, I'm looking at this 45 right here. The opposite side from that 45-degree angle is negative radical 2 over 2. That's the opposite, and I divide that by my hypotenuse, which is 1. Well, we know that any number divided by 1 is just itself. So in this case, the sine of 15 pi over 4 is equal to negative radical 2 over 2. That's your final answer. That is the sine of 15 pi over 4. Remember, when you see the sine of 15 pi over 4, 15 pi over 4 is just an angle. It's just like 45 degrees is. Okay? Alright, let's do another one. If you have questions on this one, pause it, jot them down. We want the cosine of negative 7 pi over 4. Alright. So I'm starting here. Remember, negative goes this way. 7 pi over 4. Well, let's just do a quick little division. 4 goes into 7 one time. 1 times 4 is 4. This is a remainder of, I have 3/4 showing up again. This is 1 3/4. Okay? Boy, that got really sloppy. Sorry about that. Let me put that up here. 7 divided by 4, you get a 1, 4, remainder of 3, put your remainder over your divisor. So I want to, this is negative now, this is the same thing as doing the cosine of negative 1 3/4 pi's. So I'm going to start over here, and I want to go 1 whole pi, so in the negative direction, 1 whole pi takes me to there. And now I want to do another 3/4 of a pi. So here is a half, to there would be 3/4. Okay, if you cut that last quadrant into fourths, that's where we'd be. So that's very similar to the last one we just did. So my line is going to go there. That's where my angle is going to be. Okay, I'm going to get rid of this up here now because I need that space. Maybe if I just put like a little line here, you'll know that that's the conversion. Okay, so I know this is a 45-degree angle because I just cut that last quadrant into halves. Okay. I know that my hypotenuse is 1. So I'm right back to where I just started. Now, heck, once you start doing these, you'll know that you can just refer back. If we refer back to the previous slide, when it's a 45, 45, 90, I get square root of 2 over square root of 2. So this is going to be square root of 2 over 2. This is going to be square root of 2 over 2. This time they'll both be positive because I'm going to the right and I'm going up. So cosine, if you remember cosine is adjacent over hypotenuse. If I look at my 45-degree angle, adjacent's going to be square root 2 over 2. Well, it really doesn't matter in this case because they're both square root 2 over 2. So I'm going to have cosine of negative 7 pi over 4 is equal to adjacent, which is square root of 2 over 2, over hypotenuse, which is 1. And we know that any number divided by 1 is just itself. So we have cosine of negative 7 pi over 4 equal to square root 2 over 2. Square root 2 over 2 is the value of the cosine of negative 7 pi over 4. Alright, one more of these. The sine of negative 2 pi over 3. Now I don't have to convert anything here, but what I do have to consider is the fact that I want 2/3 of 1 pi. Alright, so let's see here. 1 whole pi would be here, going in the negative direction. If I split it into thirds, it would be like here and there. That would be splitting it into thirds. But you have to ask yourself, how many degrees is that? Well, think about the fact that 1 pi is the same thing as 180 degrees, right? Half of the circle is 180 degrees. So 1 pi being 180 degrees, each third of a pi, you cut 180 into 3 pieces, is going to be 60 degrees. So really what I need to do is I need to start here. This would be a third. This would be 2/3. 60 degrees plus 60 degrees. So I'm going to draw this angle here, knowing that this here is 120 degrees. But when I draw my right triangle, I go up to the x-axis. So this portion here has to be 60 degrees. Okay? Now the other way you could do that is if you have your little I drew that wrong, but you probably already know that pi over 3 is 60 degrees. Okay, so for every pi over 3 you have 60 degrees. Alright, so now that I know that's 60, I'm going to throw my little template on here for my 30, 60, 90s. This is 60, and this is my 90. My shortest side is n, my hypotenuse is 2n, and my middle length side is n radical 3. In this case, I know that my hypotenuse is 1 because the radii are always 1 in the unit circle. So I'm going from here to here. I'm going to divide by 2. So my short side is going to be 1/2. Okay? To go from my short side then to my long side is to multiply by radical 3. So when I do a 1/2 times radical 3, I get radical 3 over 2. That's my long side. And you will see these numbers continue to show up over and over again. So I know when I'm doing sine, I do opposite over hypotenuse. So I have sine of negative 2 pi over 3 equals opposite of the 60 is radical 3 over 2. Now this is going to be negative because I'm over here in quadrant 3. So this should be negative radical 3 over 2. My radius is 1, positive 1. Even though we're down there in that quadrant, it's a positive 1. So Any number divided by 1 is just itself. Negative radical 3 over 2. That's the value. I'm sure there are going to be questions. I expect there to be questions, and I expect you guys to ask me great questions when we're working on these in class. Okay? Thank you.